So, cards on the table. This video was supposed to be about genetically engineering a real dragon, and rest assured, that video is still in the works too. But over the last few days, prior to my conceding to pander to this genre, YouTube, in all its infinite algorithmic wisdom, has seen fit to inundate my suggestion feed with videos pertaining to this new horse girl game that's apparently supposed to be the new Genshin Impact. And while I am known to be partial to this general breed of waifu fodder, I need some pocket arcade casino like a cat needs water, so I was inclined to let it slip by me unannounced. However, that was until I saw a video from Mujin, wherein he explained the actual history of the concept of Uma Masumi in Japanese culture. And also, he showed a couple of tweets from this man, Jiang Kui-hei, a genetic scientist who went to prison for 3 years over forging the ethics papers regarding his experiments in genetically engineering babies. And to precisely nobody's surprise, who's been on the internet for longer than it takes a newborn foal to be able to walk, when the internet got word that he was out, the first and only question on their minds was, so when are we getting Catgirls? Learning this proceeded my casually researching the topic on YouTube, and upon coming back strangely negative, deciding here was a hole it was my sworn internet nerd duty to fill. But I'm not a biologist. My knowledge of genetic science pretty much starts and stops in middle school. While I could have spent whole weeks trying to coax the answers I sought out of Google, which has been increasingly cagey with that sort of thing lately, I instead decided that if I'm stuck in the universe where Horse Girl Racing Simulator is the top-selling form of entertainment to the supposedly most advanced species the Earth has ever known, then why should I not at least humor the entity who'll no doubt inherit our old mess of a world in the not-so-distant future by the look of things? So, in the spirit of sinning against nature, ChatGPT and I put our heads together and drummed up a possible methodology for how, in the admittedly not-so-distant future, humans may have totally platonic relations with our very own custom-coded Kiniri Fujin, which, according to Google Translate, can either mean cute wife or pet wife, depending on how you translate it. And this is an important distinction since I don't mean to discriminate against anyone's Tsukina Dobudutsu. In theory, the process for genetically engineering a cat girl should be more or less the same for engineering a fox or a horse, or even a dragon girl, should this suit your fancy. But we're getting ahead of ourselves. As with any other engineering project, before we can buckle down on the how, we first need to know the what. Specifically, what sort of creature are we attempting to create? And I don't just mean physically. What sort of temperament do they have? How near to human are they intellectually and emotionally? And I will be skipping right over the philosophical and ethical side of whether such a being would have free will or not, and thus whether or not would be able to consent to conjugal relations, since this would be a separate topic unto itself. In fact, I may just make that a part 2, depending on how well this video does. But anyway, for right here and now, let us get down to brass tacks. Phase 1. Trait specification. As should be fairly apparent, we're going for a hybrid of human and animal characteristics, although just to what order remains up for interpretation. Given the carnal nature of these pursuits, I'm going to assume we just want the more enticing bestial aspects, i.e. minimal body hair, probably nothing with scales or claws, and nothing that overly clashes with the human physique so as to elicit a disgust reaction. As for the human side, anime girls are already a more or less even mix, at least in the head and face, of neotenous human and feline aspect ratios and proportions, with large eyes, a small, blunt snout, narrow chin and jaw, and overall rounded features. Essentially, we're probably going to need to make this a multi-generational procedure, with the Homophilus familiaris mulier prima, or faunus for those who are allergic to pretentiousness, being our genetic foundation, or common ancestor, and the various animalis crescentia working like Pokemon evolutions or progenic branches. The nice thing about all of this is that our manufactured amorous trysts will always come standard with the enhanced feline senses, reflexes, and agility. So not only will your waifu be a treat on the eyes, she'll also serve double as a house and bodyguard should such needs arise. But now on to the real business part of the formula. Also, all the following phases will be the same for both the prima and the secunda stages, so I won't waste time going over them more than once. Phase 2. Gene source identification and editing. This part is actually the easiest, since all the requisite techniques and technologies are fairly well understood and currently exist. Some of them you can even source online and do yourself at home. I'd recommend the YouTube channel Thought Emporium for examples of that. I'll have a link to him down in the description. However, you'll notice I said easy, not simple. That's because if you've seen the first installment of my Project Ubermensch series, where I'm essentially attempting to both copy and improve upon God's genetics homework, you'll be aware of just how far removed these two terms are in this context. To achieve the ideal anime aesthetic, we're going to need the aforementioned characteristics of the common house cat, as well as the human neoteny genes, some custom melanocytes to achieve any unnatural eye or hair colors or patterns, cartilage-shaping genes to get the oversized eyes to wear the same expressiveness as those of a human. On top of all of that, we're obviously going to have to do some cranial bone reshaping to make room for the hominid brain case and molars, since presumably we don't want ours to be an obligate carnivore, inside of an otherwise feline skull pattern. As well, we could isolate some genes for bioluminescence if we wanted her to have glowing eyes or accents. Though I think personally chromatophores would serve a similar purpose while having the side benefit of being consciously toggleable. I don't know about you, but for me, having a GF whose hair glows in the dark would be cool, right up until the point I had to try to go to sleep next to them. But anyway, here's where things start truly getting technical. And as a consequence, it's where I had to start leaning heavily on my AI intern. So while I've done my best to try to corroborate the following with actual hand-foraged articles and genetic research, there's still a substantially above 0% chance that some of what I'm about to say is either inaccurate or incomplete. So take it for what it's worth, by which I mean with an entire ocean's worth of salt. That said, in order to create a functional, that is, actually biologically feasible chimeran hybrid, each and all functional animal traits have to be genetically identified in their parent, e.g. FOXP2 for vocalization, PAX3 for ear development, TBX3 for limb identity, etc. Mapped onto human-compatible loci, so they express in the right places and times, and where necessary, modified or fused with human regulatory elements to avoid immune rejection or developmental chaos. Again, I'm going to point you towards a video from Thought Emporium wherein he explains the entire technical process of genetic modification and engineering, since he actually has a degree in this stuff and has actually performed genetic therapy on himself to alter his lactose intolerance, so he could explain far better and with more force of experience than I ever could. However, since I already went through the legwork of having ChatGPT gather and categorize a bunch of genetic variables, and since letting such chaos seedlings go to waste is against my religion, I'm going to put these up here on screen for anyone who maybe wants them for a science fiction or science fantasy story or something. In any case, let us move on now to Phase 3, embryonic creation. Once we have the codex of our prospective organism, the next thing we'll need is somewhere for that nascent seedling to grow into an actual organism. For this, we have a few options. We can, A, develop the whole thing totally synthetically in a lab, which would involve reprogramming the existing somatic cells of an adult human or faunus female into what are called iPSCs, or induced pluripotent stem cells, essentially creating a totally blank canvas off which to build our neovitae. Then, using a blastocyst scaffold or embryo-like structure like blastids or gastruloids, whose definitions you can pause and read on screen, to seed these with our synthetic genome. After this, we'd further guide the development of our embryonic specimen using morphogen gradients and controlled gene expression cascades. Basically, think of this like setting up an elaborate string of dominoes. Drop the first few in just the right order and the rest will follow suit, forming the desired pattern. The advantage to this method is that it allows us to bypass the need to design our fetish pets with reproductive systems of their own, which not only makes the design and construction much simpler, but making them sterile from the jump also means we wouldn't have to worry about rampancy incurred through random selective processes. In other words, we're less likely to end up with a Cronenberg-style monstrosity on our hands. Or option B involves creating a baseline human or faunus zygote, or fertilized egg, via IVF, then injecting our designer genome into it, after which we'd use electroporation or viral delivery to insert large DNA constructs, such as those for whole animal features like horns or tails or wings or whatnot. From here comes the word that's probably going to get this video flagged: epigenetics. There's no two ways about it. Unless we can gain access to hyper-advanced computer simulations of embryonic development, we're going to have to put our creation through a trial-and-error phase. There's no nice way to say it, so I'll not beat around the bush. We're almost certainly going to have to crack a few eggs to make our omelets. That said, we're not completely hapless to the whims of nature. We have the technology. By using controlled morphogenesis, we can coax embryos to grow their animal features while still supporting viable, healthy human physiology. This entails designing and employing custom signaling molecules to initiate and inhibit growth in non-human configurations, using epigenetic reprogramming to silence unwanted animal behaviors or developmental side effects, e.g., excessive fur, animal instincts or brain structures, etc., and tissue patterning scaffolds like extracellular matrix gels to guide 3D growth, particularly in synthetic or ex vivo development. Again, I'll put links to several other videos where you can source correct me on all this techno-babble. But needless to say, this is by far the most rigorous and tedious part of the whole ordeal, as a single error anywhere can cause any one of 100,000 errors to bloom into a cascade of fatal mutations. It's a bit like building a custom modular operating system or game engine from the bottom up using the open source scrap code of 6 completely unrelated programs. Only, I'm pretty sure bench testing computer code doesn't usually involve completely rewriting it and rebuilding large sections of the hardware whenever it crashes. Anyway, once that's all done and dusted, onto phase 4, gestation. We have our seed. Now we need someplace warm and fertile to plant it, i.e., we need a womb. Either one artificially generated or naturally selected, i.e., we either need to find a viable surrogate, which seems unlikely given that we're speaking of incubating a wholly novel organism, or more soundly and ethically, if you care about that sort of thing, creating an artificial womb. As far as my research has been able to turn up, this seems to be the main bottlenecking hurdle for us at this present moment. We've got all the in vitro/CRISPR stuff pretty much down to a science, so to speak. But now it's just a matter of how the heck we go from a clump of prototypical genetic slop to a fully realized neo-animal, since we'd likely have to heavily genetically modify whatever surrogate we were going to use regardless. To my mind, it seems more pragmatic to just go straight for that next step and wholly develop an artificial carriage to carry our nascent creation to term. Now, obviously, if I knew how to do this, I wouldn't be making a YouTube video about it. I'd be off sunbathing on a private island somewhere winning all the Nobel Prizes while showing Elon Musk the size of my "Look at my horse." So this part's more of a to-do list than a how-to guide. Right, so first thing we'll need to do is encase the embryo in some form of sterile bag filled with amniotic fluid. This will connect to oxygen and nutrient supplies, as well as waste extractors. Using real-time imaging, MRI, OCT, etc., and most likely AI-based diagnostics systems to monitor and regulate growth, this method would prove ideal for fine-tuning at least the original specimens of our anime harems. Next up, phase 5, neurological and behavioral tuning. Okay, remember how I said we were going to set philosophy and ethics aside for this little venture? Well, yeah, turns out that's not really going to be an option. Again, given what we know everyone's eventually going to want to do with their nouveau faunal GF. So, in the interests of keeping us from getting too derailed without appearing overly insensitive to the severity of the topic, let us very quickly skim over the topic of consent. In short, what is consent? Well, if we take consent to mean a conscious, deliberate, willing agreement to participate in a certain activity or to be party to certain terms, then there's 3 main components here to consider. First, awareness. Does the individual have prior knowledge and/or understanding of what they're agreeing to? Second, volition. Does the individual have the ability to express their agreement? And more pertinently, do they have the ability and freedom to express disagreements or concerns regarding the terms or actions they're being presented with? And third, power. Does the individual have the power, the ability, to remove themselves from the situation should the terms or activities on offer prove disagreeable? In other words, do they have it within their power to refuse? If the answer to any one of those 3 questions is no, then the individual cannot give consent, as they cannot be said to have been given any actual choice in the matter. Now, the next and most obvious question we need to at least ponder: how, if at all, can we work or design or engineer our way around this problem? Well, the shortest and simplest answer is the same as pretty much any time there's a chink in the super soldier creation process, i.e. just use a robot stupid. They're cheaper, more durable, they don't age or get sick, they come with an on-off switch, and you don't need to worry about their wants or needs because if you've designed them correctly, they won't have any apart from needing to be charged up occasionally. And once they start getting really advanced, they should even be capable of performing their own basic self-repair, routine maintenance, and cleaning. However, if you're determined to go about this the messy way, you could always alter their neural matrices so that they look at you the same way a dog does, i.e., design them from the ground up to where their central imperative is to please you. Alternatively, you could just meet in the middle and put computer control chips in its brain. I won't even hazard to guess the sorts of wicked tricks people would enslave onto those circuits. Nevertheless, it is a possibility that's worth keeping on the table, even if only to inform whatever the post-epigenetic apocalypse version of the Geneva Convention is. And lastly, Phase 6, cloning and breed stock creation. If this video doesn't get age restricted, you'll have to start calling me Julian Wolf, because I'll be a monkey's uncle. As I said before, a living sensual companion, no matter how well or sturdily they're designed, will eventually succumb to one of the many malefactions of biological orchestry. So to avoid having to go through all that again in however long the average prototype homunculus's lifespan is, we're going to want to install a procreative feature, though how exactly they'd go about using it, given that circa 99% of all phenotypic instances are going to be female, is again another topic I'll leave up for future discourse. For now, once we've achieved a viable, stable genetic model, we again have several options for a legacy transference. Option 1. Somatic cell nuclear transfer, aka embryo splitting or cloning. Option 2. Create breeding stock, i.e., specimens meant exclusively as surrogate wombs. Or Option 3. Use controlled generational selection to refine desired traits. Basically, just accelerated breeding. And there we go, sort of. Well, okay, not even vaguely. It's become abundantly clear to me that this is going to need a part 2 in order to even attempt to cover the rest of this subject in its fullest detail. So if you're down for that, you know how to make those feelings known. And of course, don't forget to like and subscribe while you're down there. Check out the links in the description to my alternate platform channels and social media. Come join me over on Discord if this is the sort of nonsensical discourse you like to partake in. And also don't forget to toss me a coin via my Amazon, merch store, or Patreon if you like what I do and think I should get paid for it. And in any event, as usual, until next I see you all my friends, stay safe, stay sane, and always remember, every great leap always requires some sacrifice. Peace be upon you.